If you've at all been paying attention to the news or media recently, you've probably come across the term quantum computing. As quantum computing becomes more mainstream, more and more people are, understandably, struggling to explain what quantum computers really are, how they work, and the fundamental concepts surrounding them. IBM Quantum is the world leader in quantum computing. We have the most sophisticated quantum program in the world, and lots of dedicated free educational content so that you don't have to feel left in the dark about what's going on in the space. Today, I'm going to answer the most common questions about quantum computers, like why they look the way they do, how they work, and how they will be used in the future. Let's get started. Question 0, because of course here we're going to start from index 0. What is quantum computing? Well, quantum computing is a new way of performing computations based on the principles of quantum physics. Unlike traditional computers, which use bits, the smallest unit of information, represented as either 0 or 1, quantum computers use quantum bits, or qubits. Qubits introduce a different behavior to computation by leveraging superposition, meaning they can exist in a combination of 0 and 1 simultaneously, rather than being restricted to just one state. Another key property of qubits is entanglement, where 2 or more qubits become intrinsically linked, such that the state of one qubit instantly influences the state of another. This phenomenon defies classical physics and allows quantum computers to process certain types of information in a fundamentally different way. By harnessing superposition and entanglement, quantum computers have the potential to solve certain types of complex problems far more efficiently than even the fastest classical supercomputers. They could one day excel in areas like cryptography, materials science, optimization, and simulation, which include tasks that would take traditional computers hundreds or even thousands of years to compute. Number 1, why are quantum computers so cold? Most quantum computers are kept at insanely low temperatures, around 10 millikelvin or minus 459 degrees Fahrenheit, because any amount of heat or thermal energy can disrupt their fragile quantum states. In addition, IBM quantum computers also need to be cold because they run on superconductors, which is a type of metal where current can flow with no resistance below a certain threshold temperature. Number 2, why are quantum computers so hard to build? All new breakthrough technology is hard to build at first and even harder to scale. But quantum computers are especially difficult because they combine so many complicated aspects of science and technology. There's a lot of new physics we are learning and need to be able to understand to build them, while also incorporating state-of-the-art engineering and programming techniques. In addition, we're also fighting against quantum decoherence, the natural tendency for quantum computers to lose track of their quantum information over a period of time, sometimes in the middle of a calculation. Keeping quantum processors isolated, but still being able to control them, is one of our biggest engineering hurdles. Number 3, why are quantum computers so big? So quantum computers themselves aren't actually all that big. Quantum processing units, or QPUs, are only about the size of a typical computer chip. However, all the other machinery that goes around it that is needed to keep it cold and stable and allow for the input and output of signals is what makes the whole thing look quite large. However, work to create smaller, denser cables and components is already well underway. 4, why are quantum computers being built? This is a great question. Why are we even doing all of this in the first place? The truth is that while our regular old computers are truly extraordinary machines, they can't compute every problem we'd like to solve. Specifically, even the world's best supercomputers really struggle to do things like simulating nature on an atomic scale, highly crucial for materials and drug developments. There's also room for improvement in the way we perform optimization calculations, which are needed for financial models or supply chain management. In every industry, it's not difficult to think of a computational problem that bring regular computers basically to their limit. In essence, there exist problems so complex that we don't know how to solve them efficiently with a classical computer. But with a quantum computer, we could. 5. How do quantum computers work? Quantum computers harness the behavior of atoms to compute by different rules than regular old classical computers do. They don't perform operations faster than a regular computer, but they can perform different operations that your classical computer can't. And sometimes those operations offer a faster route to a solution. 6. How do quantum computers break encryption? Well, right now, they do not break encryption. However, that is a real concern many have because a theoretically powerful enough quantum computer could be capable of running Shor's algorithm, which is an efficient algorithm for finding prime factors of large numbers. The difficulty of this task is actually the basis of RSA encryption, one of the standard encryption methods that is implemented all over the world. But no one has a machine capable of that yet. To prepare for this, however, we are already developing other encryption schemes that would be safe from quantum hacking. 7. How do quantum computers process information? Quantum computers process information by running quantum gates on quantum bits, or qubits, not dissimilar to electronic gates ran on regular bits. For example, the AND or OR gate. There are quantum counterparts that allow the qubits to take advantage of the uniquely quantum properties that they have. Putting all these gates together creates a quantum circuit, which is a series of instructions for the quantum computer to follow. 8. When will quantum computers be available? Actually, they are already available to the public right now. Making an account on IBM Quantum will give you free access to IBM Quantum computers that you can use. Number 9. When will quantum computers break encryption? We don't know, but all indications tell us that it's probably quite a ways away. This might sound scary, but there are other positive benefits to building a quantum computer capable of running Shor's algorithm. That same algorithm is valuable for other things, like phase estimation. And simultaneously, the country and world are moving towards other encryption schemes that are quantum safe. Number 10. When will quantum computing become common? The truth is, we can't predict this for certain. Hopefully, and we think pretty soon. If you subscribe, you'll be one of the first to know. And if you have any further questions, please drop them in the comments. We'll see you next time.